Hello, welcome back to AWS AI Infrastructure Day. I'm Jasmine, joined here with my co-host AM.
It's me.
We're going to be here all day, and we're joined by our first guest, Sudhir. Sudhir, tell us who you are.
Hey everyone, this is Sudhir. I'm a specialist solutions architect. My focus area is confidential computing. Been with AWS for about 6 years now. I'm based out of New York.
Yeah. Awesome. So what are you talking with us about today?
So my topic's going to be secure AI with confidential computing. So it's going to be a very interesting mix of those two and have a cool little demo, and we'll see how both of these two tie together.
Yeah. Okay, so getting started right in, we know that security is job zero at AWS. So
Absolutely.
What does this mean? You know, you're talking about confidential computing. How does it all tie in together with AI?
Absolutely. So like you said, security is job zero. And when it comes to secure AI, the way we approach that at AWS is we define that using three principles, right? The first principle being securing AI data, which is models and weights, including the prompts, the data in the prompts, from the operator and the infrastructure operator, which is AWS, right? So that principle one is all about protecting customers' AI data from us, AWS itself. Now, principle two is where we want to give customers a mechanism to isolate and separate their own AI workloads from themselves, right? So think about running the highly sensitive AI models in an isolated execution environment, so on and so forth, right? And principle three is extending that to beyond our AWS Nitro system, which we'll get into the details a little bit, to the ML accelerators, AI and ML accelerators, the NVIDIA and the Trainium and Inferentia as well. So these are the three principles, and then we'll get into details of confidential computing at AWS and how these two things come together.
Sudhir, I've got a little bit of a background as a security practitioner myself, and what I was learning talking with you yesterday in preparation for today's event, a lot of the same characteristics that you would approach any workload apply to approaching an AI workload as well in a security fashion, right? So
Absolutely.
when you're evaluating the security of one of these workloads, you kind of take the same approach as you would anything that's going to be dealing with sensitive data. Is that right?
Absolutely. Well put. In fact, I think this is a great segue into what confidential computing is, right?
Please, yeah.
So, and again, confidential computing, the terms means a lot out there, but at AWS, for us, confidential computing means protecting the sensitive data and code while it is being used. And we do that using specialized hardware and firmware. And naturally, the question becomes, now, who are we protecting it from, right?
Mm-hmm.
When it comes to that, we talk to a lot of customers, and based on their feedback, customers do think about the protection they need in terms of two dimensions, right? So dimension one is where customers have asked us that, hey, I need protection for my sensitive code and data from you, which is the cloud operator, AWS, right?
Right.
And dimension two is where they have said, hey, I need a mechanism to isolate my own workloads, the sensitive code and data, from my own operators and other components of their architecture, right? So these are the two distinct dimensions. Again, dimension one is protection from us, AWS operator. Dimension two is a mechanism to isolate and segregate their own workloads, right? Now,
I was just I don't mean to interrupt here, but I think the theory is great, but I know you've got some actual, example workloads. Maybe
Absolutely.
we should jump in and show what's on your screen already.
Absolutely.
And put it into more of a context of a real workload, because step one is probably identify where the sensitive data is in the workload, right?
Exactly. And I tend to think this in terms of a multi-party collaboration problem, right? So what I'm showing here on the screen is, think of this like two parties coming together to solve a particular problem, right? And this happens to be a problem where you want to use LLMs or SLMs or ELMs for that matter, right? So the visual that I have on the screen here, party A wants to consume the LLM models, for a simple example being they want to set up a chat interface, right? So think of that, think of party A as the consumer of the LLM models, and then party B to the right of the diagram is the party which actually owns that, right?
Yeah.
So these two parties are coming together. Now, what they do want is assurances to protect those things that I'm showing on the screen, which is the prompt, the sensitive documentation, and the internal data stores of party A. And from party B's perspective, they want to make sure that their model that they have spent so much resources on training and fine-tuning and whatnot is not being exfiltrated out, but yet still they want party A to consume it.
Yeah.
So that's how it's a multi-party collaboration problem. And then we'll actually go into details about 3 very simple patterns in which this is applicable, and then we'll see how AWS confidential computing services are going to solve that.
Okay.
Yeah.
They help you mitigate
The risks and the attack surfaces. Yeah,
Yeah. So these are built-in security and privacy features.
absolutely.
Yeah.
Absolutely.
And so what does that mean for customers? How are they using this?
That's a great question, right? So before we get into the weeds of the solution, if I just want to tie back to the dimension model, right? So dimension 1 of confidential computing, the way customers mitigate against that is by simply using any latest generation EC2 instance, Amazon EC2 instance, right? So AWS Nitro system is the underlying platform of any latest generation Amazon EC2, and that is the platform that gives that isolation characteristics where AWS operators have zero access to customers' workloads or EC2 instances.
I think that's really important to call out because that's one of, a very common mitigation tactic and tool in the tool belt. I don't know what to call it. I wear a belt, I guess. The tool belt of any security practitioner is isolation, right? And there's different ways to isolate different types of things. Tell us a little bit about the isolation in the Nitro Enclave. Can you go into a little more details about what that means in terms of isolation?
Great segue again. So dimension 1 was, pretty simple, right? You don't have to really do anything, just pick the latest Amazon EC2 instance. Now, dimension 2, the thing that you're asking about, the Nitro Enclaves, right?
Right.
The answer to dimension 2, where customers want a mechanism to isolate their own workloads, is AWS Nitro Enclaves.
Yep.
With AWS Nitro Enclaves, we have tried to make it a very simple experience for customers to consume. And the way it's going to work is customers package up the application that they want to isolate from the rest of their architecture. They will containerize it, and they'll use some open source toolings called Nitro CLI, etc., to go deploy the application into an isolated execution environment called Nitro Enclave, right? And there are a couple of very key features of Nitro Enclaves, or characteristics for that matter. We'll go into those details. These are the characteristics that are the primitives, in other words, that gets reused over and over again. And in fact, we'll actually see how those primitives are applicable for this generative AI workload where you want to protect LLM model, but still consume it.
Okay,
Yeah.
great.
Yep.
Okay. Let's see what you have for us. You have demo for us, and we're going to keep going through this.
Absolutely. And then I'm going to switch back. And I promise there's only a couple of slides.
Yeah.
I'll switch back and forth between the demo. So here, what I'm showing on the screen is a simple LLM-based application pattern where, party A, if you see on the left-hand side, has a simple client application. It's a chat interface, right? This is where you want to type in your prompts, ask the questions away to the LLM. And off goes that prompt to the right-hand side of the diagram, which is party B, which is the owner of the LLM, right? So simple setup. Let's actually see what the issues with this pattern are before we get into the solution.
Yeah, where are the pieces of sensitive data flowing?
Exactly. So depending on the use case, right?
Sure.
So imagine this is an LLM which is in the healthcare space where your patients are asking about their condition, describing their conditions, and asking for a diagnosis or remedies, etc. Right? So the sensitive data will be in the prompt and the additional context, the query that you provide as input from the client side.
Yeah.
And then once this input query hits the LLM, think of this LLM again as a fine-tuned model specific to the healthcare domain, right? So there is quite a bit of IP, intellectual property, built into the LLM. So these are the 2 areas highlighted in red that you want to protect from either party, right? So party A wants to protect their prompt query, party B wants to protect their LLM model. So let's actually see how we solve this using AWS Nitro Enclaves.
Yeah, let's see that.
So with that, I'm gonna switch over to my demo and pull up the console real quick. All right. So like I said, with AWS Nitro Enclaves, it's a feature of Amazon EC2.
Okay.
Right. So it's almost like a checkbox experience. So what I'm showing here on the screen is an Amazon EC2 instance. And if I just scroll down here, if you see the section where it says Enclave Support Enabled, this is the single checkbox where you can pick an Amazon EC2 instance and enable Nitro Enclaves on it. Once you do that, what you get is I'm going to use AWS Systems Manager, Session Manager to log into the instance here in a second. And then I'm going to use an open source tool called Nitro CLI, which we are open source. It's up there on the GitHub. We'll throw the links in the chat. But using this, I'm going to just say, hey, describe the enclaves. And by the way, the infrastructure for this particular demo, most of it, I don't want to bore you with the details. So I have bootstrapped it ahead of time. So what you will see now is an enclave up and running, right? The important things to notice here are these, right? With Nitro enclaves, you donate the CPUs and memory from the parent EC2, which is that Amazon instance you saw a second ago, to this sibling enclave, if you will. Okay. Right. So in this instance, I've donated 10 vCPUs and 20 gigs of memory.
Okay. So a subset of whatever resources are available in that instance.
Exactly.
You're just allocating them here to the enclave.
Exactly. And depending on the use case, right? For my example, I'm actually running Mistral 7B, the foundation model inside an enclave. So for that, I have right-sized it to about 30 GB to be performant enough and 10 vCPUs, right? So this is where the flexibility is. You can right-size this for the workload, for the enclave size, and pick the right EC2 instance. In fact, I'm running this on Graviton 3 on a C7G instance. I know there's going to be more
coming up. Get back.
Yes.
We'll be talking.
You're teasing everything later.
I believe that's next.
Yep. So one last thing I want you to take a notice of in this screen before we go to the other parts of the architecture is look at these PCR 0 values. PCR stands for Platform Configuration Register. In short, what it is a cryptographic signature of this particular enclave.
Okay.
It's a validation. It's a one-way cryptographic hash, the SHA-384 hash. It measures the contents of the enclave itself. So even if you change a single byte of what's inside the enclave, whether it's code or data, this hash is going to change.
Okay.
So PCR 0 in this case, if you see the B7CD4 string, this is what I'm taking as a signature of the enclave. And by the way, there are more signatures, but this is the measure of the entirety of the enclave. I'm using this and this is the out-of-the-box integration with AWS KMS system, key management system.
Oh, interesting.
So I'm going to switch here in a second to my KMS key.
Okay.
And we'll talk more about what this means. But if I go to the key policy, you can see here there's a conditional wherein I put the PCR 0 value against an action called decrypt. So what I'm saying by this is, hey, for the data or the LLM model that's backed by this AWS KMS key, allow decrypt action only if it originates from an enclave with the specific signature. This is called cryptographic attestation. Right. And what you're seeing here is out-of-the-box support for cryptographic attestation between Nitro enclaves with AWS KMS.
Yes.
What do we achieve by doing this? So let's actually switch back to a visual, to the slide, and I'll actually show you the fundamental primitives that make all of this happen.
Okay. And as you said, anything that changes on that enclave will change the SHA hash, and that's part of the validation.
Exactly. So if I quickly scroll to the slide, excuse me here. All right, so here it is. So we started off with party A and party B, the multi-party collaboration problem, and we talked about how party B, which owns the LLM model, wants assurances that their model cannot be exfiltrated out.
Right.
Here's how they achieve it, right? So, and the idea is very simple. You use AWS KMS key, right? In fact, you can substitute with your own key management system. The idea here is, again, multi-party collaboration problem, right? Yep. We want to make sure that both parties can safely come together, collaborate on a problem, and achieve the outcomes without the need to trust each other blindly.
Right.
Yeah.
And that attestation that you were talking about earlier in simple terms, but not fully describing the terms of what attestation really means, it just means like being able to prove who has access at what time.
That's
right.
That's exactly right. Cryptographic attestation is a mechanism, is a way by which a Nitro enclave can tell the external world, and this external world could be an AWS service or your own service, cryptographically that, hey, I am an enclave and here is my signature.
Yeah.
All right. And tying this back to confidential computing, the protection at the time of processing, right? So how do you know that you are actually talking to an enclave at runtime?
Right.
Yeah.
Cryptographic attestation is the way.
Right.
Yeah.
And back to the screen, we can actually see how party B, who owns the LLM model, can now envelope encrypt the LLM model weights with AWS KMS key, but now go back to the AWS KMS key, and then like we saw in the KMS console a minute ago.
Actually attributing only the enclave with the SHA hash of this specific environment is able to decrypt this data.
That's exactly right. So in other words, this particular enclave can only decrypt the LLM model, waits, and then boot up the LLM, right? And no one else can. So that's the assurance for party B, the LLM owner.
Anything changes in that enclave, they will no longer be able to decrypt it because that SHA hash will be different.
Exactly.
All right. Very cool.
Okay. And do we have any types of customers that are using this? I could think of a couple of different options of types of customers that might want to use this, but what have you seen so far?
Absolutely. We have ISVs in healthcare and automotive space who are basically trying to set up data and AI marketplaces.
Okay.
So think of, again, back to this problem, you have customers of theirs who want to consume the LLM models, but now they want a way to quote unquote like seal the model with an enclave and then consume it securely. An example that we went public with, in fact, we have a great blog on this, is Lidos. Lidos is an ISV partner of ours, and they have blogged on exactly this, how to use AWS Night Enclaves to run a LLM inside it.
Yeah.
So I know you had a few other patterns, Sudhir. We're running short on time. Do you want to pick maybe one of those and go into it? I know you had one about an anonymizer. You've got I'll let you choose.
Sure. All right, let's look at pattern number 2.
Okay.
This is building on top of pattern 1, but the fundamentals and the primitives still remain the same, right? So think of pattern 2 is where a client now still wants to talk to LLM, but guess what? They've figured out that, hey, my prompts and query could potentially have sensitive data. And what they did is they introduced a module called anonymizer. The function of this module anonymizer is to take the sensitive prompt and sanitize it, right? So essentially removing the PI data or anything that is sensitive for that matter, substituting it with equivalent strings which really don't mean anything, right? So that's the anonymization part. And then of course that sanitized prompt to the LLM, the response back from the LLM is essentially swapped back, desanitized, right? So you want to substitute those strings, the encrypted strings, if you will, or the tokens back to the real data so that the response back to the client actually makes sense. So this is another popular pattern. If you look at the threat surface or the attack surface here is a little bit more than pattern 1, right? So now you have the prompt, which is sensitive, yes, but then the anonymizer module itself.
It's taking in that sensitive data from the prompt.
Exactly. So left-hand side of the anonymizer takes in the sensitive data. So you want to protect that. So in this example, we'll actually pack up the anonymizer into an enclave.
Oh, interesting. So that's an interesting question. Would you run the anonymizer in one enclave and the LLM in another enclave?
Absolutely. Absolutely. And in pattern 1, we have already seen how to run an LLM inside an enclave. So as far as the demo goes, we'll simplify it and we'll actually be using Bedrock for the LLM. And then anonymizer is going to run in an enclave.
Okay. I'm going to let you get to it because we only got about 2 minutes.
All right. And again, let me kick off the deployment here. By the way, you can try this workshop out yourself. We have made this public, and there's 2 experiences. We can run this for you as an event, or you can download the source code and look at how we have built this.
Sudhir, we're still seeing your PowerPoint. Do you mind? Are you switching over to the console?
Oh, yeah. Yes.
Yeah, I think you have to hit the escape button because you're full screen.
Right. I think we did. I think we did. All right. So this is what I was trying to show. We packaged this entire solution up into CI/CD pipeline. So what I'm actually trying to do here is I have 2 applications, right? The application that is running now, which we looked at, the internals was the LLM in an enclave. Now the second one is the anonymizer in the enclave. So what I'm going to do is go ahead and deploy this, right? Let it run. But then if I switch back to the slide deck, let's look at the solution while the deployment is running, right? So I'm going to go to, if I can maximize the screen again, I'm going to go to the solution of pattern 2. Bear with me for a second. Here we go. All right. So I know this is a busy slide, but what I want you to focus on is look at the right side of the architecture diagram, which is where the enclave is. And the idea is simple. Look, the anonymizer runs inside the enclave. For the anonymizer to function, the way we have built this, and this is not the only way, is anonymizer identifies the sensitive strings in the prompt and then substitutes it with an encrypted token.
Okay.
And the way it does that is it gets the cryptographic material from AWS KMS.
Okay.
And with cryptographic attestation, you can again scope down this function so that only anonymizer can get that cryptographic material and no one else.
Yeah.
All right.
So that's how we are trying to mitigate the attack surface around the anonymizer itself.
Sounds great. We are out of time, Sudhir. I feel like we could keep going.
We could keep going.
Quite a long time.
This definitely makes me want to go try the workshop that you just mentioned. We're dropping the blog post links here in the chat. But if you want to learn more about how AWS has designed the Nitro system securely, we have something coming up for you right now. So stay tuned and we'll be back with another live guest.